From the street, the glass towers of Dubai look completely untouchable. They stand perfectly still against a clear sky, projecting an image of absolute permanence. But under a microscope, the desert is telling a very different story. A perfect glass facade is not destroyed by one dramatic moment. It is weakened by small things repeated over many years: a profoundly hot afternoon, a shaded edge cooling too fast, a single grain of sand carried by the wind, a heavy cleaning blade wiping across a surface, a tiny flaw invisible to the naked eye. Individually, none of these look like a crisis. You will never see a headline about a single scratch. But together, they create the one problem this city cannot market its way out of. That is the overwhelming cost of keeping a glass metropolis looking young in the middle of a harsh desert. This is not a story about a massive tower collapsing tomorrow. It is about something much quieter and far more expensive. What if the first sign of structural exhaustion is not a shattered skyline, but a maintenance bill that never stops growing? Could Dubai be walking into a $50 billion maintenance trap? To understand the true scale of this quiet crisis, we have to look closer. We have to stop looking at the tower as a monument and start looking at the glass as a vulnerable surface under constant attack. Look at a single sheet of architectural glass used on these massive structures. From a distance, it appears flawless. It looks clean, expensive, and almost weightless. Now imagine placing it on the side of a tower in Dubai at high noon. The center of the panel heats up rapidly under direct solar radiation. Meanwhile, the edge of that same glass, hidden inside a thick metal frame, stays much cooler. One part of the glass desperately wants to expand. Another part holds it tightly back. Nothing dramatic happens in that exact second. There is no loud explosion. There are no screaming tourists running for cover. There is no breaking news, but the material is experiencing silent tension. Now add 1 grain of desert sand to the equation. The wind blows it across the facade. It slides across the glass and leaves a tiny mark too small for the human eye to see. Then another grain follows. Then another rigorous cleaning cycle happens. Then another blistering summer arrives. Then another aggressive dust storm rolls through the empty streets. Slowly, the most luxurious surface in the city begins to collect an invisible history of microscopic damage. This is not a claim that these glass towers are poorly built. In fact, many of them are incredible engineering achievements. Their facades are designed, tested, and maintained by professionals who understand the sheer violence of the desert better than anyone else in the world. But that is exactly why the harder question matters. What happens when the city does not have just one glass panel to protect, but an entire endless skyline? What happens when millions of square meters of glass must fight the same 3 enemies every single day? Those enemies are heat, dust, and time. A bridge failure is easy to imagine because it is sudden. A tower collapse is easy to fear because it is spectacular. But the failure of a glass city may not arrive like that at all. It may begin as a microscopic scratch near the edge of a panel. Then it becomes a thermal stress point. Then it triggers a replacement order. Then it demands a cleaning schedule that literally never ends. Then that maintenance bill quietly spreads across every new luxury tower Dubai adds to the desert. The real question is not whether the skyline will shatter tomorrow. The real question is far more dangerous. How expensive can the skin of a city become when the desert touches it every single day? Dubai did not choose glass by accident. This city built its entire reputation on a very specific visual brand. Glass represents modernity, boundless wealth, and global ambition. When you look at these towering structures, they create an illusion of weightlessness. They reflect the sky, the clouds, and the surrounding wealth, creating a cinematic atmosphere that tourists and investors travel thousands of miles to see. For a visitor walking down a pristine, quiet boulevard, glass provides the ultimate luxury view. For the engineers, however, Glass is a highly technical skin. It is a fragile barrier that must withstand extreme sunlight, heavy winds, abrasive dust, building vibrations, and the natural degradation of chemical sealants. Dubai sells an image of absolute perfection, but a brand made of glass has one brutal weakness. It must remain flawless to hold its value. A concrete building can age and still look strong. A glass building that looks old simply looks neglected. As Dubai continues to expand its tourism footprint, it adds more and more of these delicate surfaces to its map. Each new luxury hotel, every new branded residence, and every new exclusive shopping district requires massive amounts of structural glass. They are building an empire of transparency. But this transparency comes with a hidden contract. What happens when the product Dubai sells to the world depends entirely on surfaces that the desert is constantly trying to age. Is the city building wealth, or is it building a monument to future maintenance? To understand the physical toll, we need to look at how heat actually interacts with these structures. Thermal stress is a known engineering reality, but the scale in this region changes the math. A large pane of glass does not heat up evenly. When the midday sun strikes a tower, the center of each glass panel absorbs massive amounts of direct solar radiation. The temperature spikes. The material naturally expands, but the edges of that same glass panel are tucked safely inside aluminum framing systems. Those edges are often in the shade and stay significantly cooler. This creates a hidden battle within the material itself. The hot center expands outward, but the cool edges resist. This pulling effect creates immense tension along the perimeter. If the glass were absolutely perfect, it could handle this tension for decades. But glass in the real world is rarely perfect forever. If there is a tiny surface flaw, perhaps a microscopic nick from installation, or a tiny scratch from a sandstorm, that flaw becomes a target. The thermal stress seeks out the weakest point. Again, thermal stress is not a guarantee of sudden failure. It is simply a permanent load that engineers must manage every day in a city where sunlight is not a background detail, but a physical weight pressing against the skyline. Imagine an entirely empty restaurant high up in a tower. The air conditioning keeps the interior perfectly cool while the exterior burns. The glass is caught between two extreme climates. Over years of these daily heating and cooling cycles, the material experiences fatigue. If the first dangerous point of failure is hidden entirely inside the frame, how long can a flaw grow before anyone sees it from the street? Heat is only the first part of the equation. The second part is much smaller, but just as relentless. Sand does not need to break glass to defeat it. Think of your own smartphone screen. One tiny scratch does not destroy the phone, but it ruins the perfection, and more importantly, it gives the next physical impact a place to begin its damage. Now multiply that concept across a towering skyline. The desert environment is highly abrasive. Fine dust and sand particles are constantly lifted by the wind. They act like microscopic blades sliding across the surface of the towers. A massive dust storm sweeping through the financial district does not shatter the windows, but it coats them in abrasive material. When these windows are eventually cleaned, the wiping action can press those tiny particles against the glass, creating microabrasions. Over a decade, the glass is subjected to hundreds of dust storms and thousands of cleaning cycles. The surface loses its microscopic smoothness. It gathers an unseen history of wear and tear. Glass is incredibly strong when its surface tension is undisturbed, but its actual lifespan in a harsh environment heavily depends on avoiding surface flaws. A tiny scratch from a grain of sand is exactly the kind of vulnerability that thermal stress is looking for. It is an address where future damage can safely reside. If you stand in a deserted luxury plaza and watch the wind blow sand against a massive glass pavilion, you are watching a very slow, very expensive form of erosion. If each individual storm leaves almost nothing behind, what does almost nothing become after 10 years of repetition. This brings us to a fascinating economic trap. We call it the cleaning paradox. Dubai cannot simply let its glass towers get dirty. The entire tourism and real estate model relies on the illusion of pristine luxury. Dust makes glass look cheap. It reduces natural light inside high-end apartments. It destroys the visual appeal of a skyline that is supposed to signify immense wealth. Therefore, cleaning the glass is not just about aesthetics. It is a strict requirement for asset protection. But washing skyscrapers is an expensive, dangerous, and constantly repeating industrial process. It requires specialized rope access teams, heavy mechanical cradles, massive amounts of purified water, and intense labor logistics. Ironically, the act of cleaning is also a mechanical stress on the building. Water, squeegees, and suspended equipment all interact with the facade. The building must endure the weight and movement of the cleaning apparatus. Cleaning is absolutely necessary, but necessity is exactly the point of the paradox. The city is trapped in a cycle it cannot stop. If they stop cleaning, the luxury image fades and property values drop. If they keep cleaning, they must fund a massive, permanent army of maintenance crews suspended above the city every single day. The more glass the city builds, the more permanent the cleaning machine becomes. It is a subscription service to perfection that can never be canceled. What if the real cost of this glamorous skyline is not the day it is built, but every day it must be made to look new again? A microscopic flaw in a piece of glass is not expensive because it is large. It becomes a massive financial burden because it is multiplied across a city that cannot afford to look damaged. This is where engineering fatigue turns into economic pressure. If one panel fails or needs early replacement, it is a minor building issue. But a single super-tall tower contains tens of thousands of individual glass panels. The entire city contains countless millions of them. The scale changes the nature of the problem. Replacing glass on a skyscraper is a logistical nightmare. You cannot simply open a window and pop in a new one. You need specialized access equipment. You need safety inspections. You often have to block off pedestrian areas below, disrupting the quiet, luxurious atmosphere of the district. You need highly skilled labor. You must replace the structural sealants. You have to ensure the aluminum frames are still completely aligned. You have to manage insurance liabilities and coordinate downtime with extremely wealthy tenants who do not want construction noise in their penthouses. The cost of replacing one panel at the top of a tower is astronomically higher than the cost of the glass itself. Now imagine this requirement slowly increasing as the entire first generation of Dubai glass towers begins to age simultaneously. The $50 billion question is not whether every single panel will fail. It is how large the total maintenance bill becomes when every surface must be treated as a critical part of the city image. What happens when maintaining the skyline stops being a series of isolated building repairs and instead becomes an enormous, inescapable economic model? Despite these long-term pressures, the city is not slowing down. The pipeline for mega-projects and giga-developments remains massive. Dubai continues to announce new luxury towers, branded high-end residences, sprawling commercial districts, and massive hospitality venues. Every single new project adds vast amounts of new glass to the desert. It is true that material technology is improving. Engineers are using better glazing, highly advanced coatings, and stricter building codes. They are designing facades that reject more heat and resist more damage. But this has become a high-stakes race. It is a race between the efficiency of new materials and the sheer volume of new surfaces being built. Imagine a chart with two lines. The first line represents better engineering and better maintenance techniques. It is going up. But the second line represents more towers, more facade area, more exposure to heat, and more mandatory cleaning cycles. That line is also going up, and it is multiplying rapidly. If you walk through a newly built, almost deserted luxury marina, you are surrounded by miles of pristine glass, facing the harsh sun. Is Dubai making each square meter of glass stronger faster than it is adding new square meters to the desert? Every new tower that rises is not just a new icon for the tourist brochures. It is a new surface, signing a very long, very expensive contract with heat, dust, and time. Can technology outpace the sheer scale of the environment? We must be absolutely clear about what failure looks like in this context. The real failure is not a catastrophic collapse. The towers are safe. The engineering is highly regulated. You are not going to wake up to a city of shattered glass. That is a Hollywood scenario, not an economic reality. The actual failure is much more subtle and much more likely. It looks like a slow bleed of capital. It looks like maintenance schedules becoming more frequent. It looks like building service charges skyrocketing for investors. It looks like insurance premiums rising to cover the increased risk of facade degradation. It looks like older buildings becoming too expensive to retrofit, causing them to lose their luxury status rapidly compared to the newer towers. The city has massive financial reserves, brilliant technology, and top-tier engineers. But money and technology do not delete the environmental conditions. They only pay the ongoing bill to fight them. Dubai's glass may not fail like a collapsing bridge. It may fail like a subscription bill that grows heavier every single year, quietly eating into the profitability of the real estate and tourism sectors. If a city can survive the extreme desert only by constantly paying billions to erase the desert from its delicate surfaces, has it truly defeated the environment? Or has it simply turned the environment into a permanent, unavoidable invoice? Tonight, the skyline still looks completely perfect. If you stand at a distance, the towers glow against the dark sky. The glass reflects the vibrant lights of the city back to itself, looking clean, sharp, and entirely flawless. It is a breathtaking achievement of human ambition. But the desert does not need to win in one dramatic moment. It does not require a catastrophic event. It only needs repetition. One hot afternoon baking the glass, one shaded edge hiding in the frame, one grain of microscopic sand scratching the surface, one heavy cleaning cycle dragging across the facade, one invisible flaw quietly growing. Dubai has successfully proven to the world that a massive, luxurious city can rise directly from the sand. The engineering victory is undeniable, but the next test is much quieter and far more relentless. It is not about building the city, it is about keeping it. Can a city made largely of glass keep looking completely untouched when the harsh reality of the desert touches it every single day? If this analysis changed the way you look at Dubai and its endless glass skyline, leave a like and subscribe to the channel. We investigate the hidden engineering costs behind the most ambitious cities in the world. We look at the complex systems that appear absolutely flawless from a distance, but become far more complicated and expensive when you dare to look closely. The illusion of perfection is always the most expensive thing to maintain. Tell us in the comments right now, which massive Dubai infrastructure system should we investigate next? This documentary is an independent engineering and economic analysis based on publicly available information. It does not claim that the towers in Dubai are currently unsafe, that a confirmed $50 billion glass failure crisis is already happening, or that any specific building is at risk of collapse. The focus of this video is on long-term environmental exposure, maintenance pressure, thermal stress, dust abrasion, and the economic burden of preserving glass facades in extreme desert conditions. This content is for educational and documentary purposes only. It is not formal engineering, architectural, safety, legal, financial, or investment advice.